All right, in this video, we're going to finish 5.2. I'm hoping that this video will be a little bit easier with some of the content. We don't have quite as many properties as what we had to go through in the previous one. So let's just jump right into this first example here. So it says, what is the sum of these radicals? Well, radicals operate a lot like variables in the sense that we can add or subtract variables as long as we're dealing with like terms. So we can add and subtract radicals as long as we're dealing with the same radical. So in this one, we have a square root and a cube root. So we can combine together the cube roots and the square roots as long as what's underneath is the same value. So I need to do some changing here. So what I mean by that is the square root of 20, let's simplify that. Now, you could do the factor tree for all these, but remember in the previous video I said, hey, if you can simplify these without the factor tree, it's going to make your life a heck of a lot easier. So here's what I noticed with the square root of 20. Since we're dealing with the square root, I'm looking at perfect squares, meaning what numbers can I break down into being a pair of the same value? So in other words, 20 is the same as 4 times 5. 4 is what we call a perfect square because 2 times 2 would be 4. So in other words, the square root of 4 times 4, or square root of 4 times 5, square root of 4 we said was 2, so this would simplify to be 2 times the square root of 5. And then I'm going to put the minus the square root of 5 here with this one. So we're going to put the squares together. And I can't simplify that, so I'm just going to rewrite that down here to be on the same line. So we'd have 2 square root of 5 minus the square root of 5. We'll get to that in a second. Now let's look at the cubed roots. We're going to do the same thing with the cubed root of 250. Now what I recognize is, okay, so yeah, the square root of 25 would be nice, but we're dealing with a cubed root. We're not dealing with a square root. So we're looking at pairs, not pairs, sets of 3 of the same number that can multiply together to be a perfect cube, in other words, that we could use. So let's stick with that, actually 25. Remember, 25 is the cubed, or 5 cubed, rather, would be 125. If I took 25 times 5, I'd get 125, which would be the same as 5 cubed. So 125 is what we call a perfect cube. And 125 times 2 would give me 250. And so the only way to really do this simple form is to just kind of play around with the numbers. So getting familiar with some of those perfect cubes, like for example, 27 is a perfect cube because 3 times 3 times 3 will be 27. 8 is a perfect cube because 2 times 2 times 2 would be 8. And 64 would be a perfect cube because 4 times 4 is 16 and 16 times 4 is 64. And 125 is a perfect cube because 5 times 5 is 25 and 25 times 5 is 125. So the more you practice these, you're going to get familiar with some of these perfect cubes and it'll make it a little bit easier. So then what you could do is on your calculator, you could say, oh, remember 125 is a perfect cube and 250 divided by 125. Oh, it's 2, so that would be one you could work with. You want to make sure that when you find a pair of numbers here that none of them are a decimal. You want to make sure that we're working with integers. So 125 is a perfect cube times 2, sure enough, is 250. So the cube root of 125 is 5, so we'd have 5 times the cubed root of 2. Now, if what I just said was really complicated for you, and if you want to do a factor tree, you can. Just know that some of those will take a little bit more time. All right, so then we have this minus a cubed root of 16. Oops, and I'm going to make that, like I said, we're trying to find perfect cubes. And 8 is a perfect cube, one of them that we talked about. So this will be the same. So 8 times 2 is the same as 16. And the cube root of 8 is 2. Now, if you're wondering, why did you do the cube root of 125 or the cube root of 250 first minus a cube root of 16? It doesn't matter. Okay, remember you can add or subtract in any order. So I just did it in this way, so in that way we'd be subtracting from another value. But if I would have the other one first, it's totally fine. It doesn't matter what order you put it in, because the next step is we're going to combine like terms. So notice what I have here in red. So these two are like terms, and so we can combine those. So this would be the same as 1 square root of 5. So imagine if I had 2x minus 1x. Well, you guys know that 2x minus 1x would just be 1x, or x. Well, let's say if we replace those x's now with square roots of 5. So 2 square root of 5, take away 1 square root of 5 would just be square root of 5. And then with the other set, if I had 5x minus 2x, you know that your answer would be 3x. Well, instead of 5x, if I had 5 times the cube root of 2 minus 2 times the cube root of 2, your answer would be 3 times the cube root of 2. So that would be your answer. Now, we cannot combine these two because these are not like terms, because we have a square root and we have a cubed root, so those are completely different roots, and what's under the roots are different values as well. So in order to be able to add roots together, you need to make sure that you're adding like terms, and by like terms, we mean that not only do the root, but also what's under the root has to be the same thing. So here we have a square root, and we have a square root, but what's underneath the root has to be the same. So square root of 5 and square root of 5, those are like terms, and cube root of 2 and cube root of 2, those are also like terms. All right, so if you want to try both of these right off the bat, go ahead and pause the video, and then you can check to see that you got the correct answer. If you're not feeling quite ready to be able to try both of these on your own, let's maybe do this first one together, and then you can see if you can do the second one on your own. So the cubed root of 2,000. Again, if you wanted to do a factory for that, you could, but you have the idea that you might be dealing with a lot of numbers. So think about this way. 1,000, well, let's not use a highlighter. Oops, let me change to a pen. Here we go. So 1,000 is the same as 10 cubed. And so 2,000 would be the same as 2 times 1,000. So that's what I'm going to do here. I'm going to look at this as being the same as the cubed root of 2 times the 1,000. I like to put the bigger number first. You'll see why in just a second. And then, again, we can only combine like terms. And so I'm only going to be able to combine these two. So with that square root of 2, I'm not going to be able to do anything with that because there's no other square root of 2. So I'm just going to move this. I'm going to switch the order here. So now I'm trying to find two perfect cubes, or not a perfect cube and another number that would combine to be 128. So I want you to sit and think for a second. What are some of our perfect cubes? And if you're not sure, if it'd be helpful to list out some of them just so you could see them visually, do this. So 2 cubed would be 8. 3 cubed would be 27, because 3 times 3 is 9 times 3 is 27. 4 cubed is 64, because 4 times 4 is 16. 16 times 4 is 64. 5 cubed is 125. If you skip to 10 cubed, remember 10 cubed is 1,000. So can you see one of these in this list that you could multiply by another number to get 128? If you're not sure, play around on your calculator, but here's what I'm getting at. 64 times 2 would be 128. Then we don't forget that we have plus the square root of 2 here in the end. All right, so let's simplify those first two. The cube root of 1,000 would be 10, so this would be the same as 10 times the cube root of 2. And the cube root of 64, that's 4, leaving us with 4 times the cube root of 2 plus the square root of 2. So even though this last one is a square root of 2, it's not a cubed root of 2. In order for us to be able to add it to the other two, it has to not only be the same value under the radical, so the radicand has to be the same, but the root also has to be the same. This is not, so we cannot combine that with the other two, but the other two are like terms. So if I had 10x minus 4x, my answer would be 6x. So if I were to simplify this, we would have 6 times the cube root of 2 plus the square root of 2. That'd be your answer. All right, we've done a few of these now. I want you guys to try this last one on your own. So this one, you're going to simplify these. Even though they're all square roots, you need to make sure that in order to combine them, you need to have the same root and the same value under the radical. So the radicand has to be the same. So you have to have the same root and the same radicand. So you're going to simplify all three of these to see which one or which ones you would combine together. So go ahead and try that. Pause this and then hit play when you're ready to check your answer. See how you did, and I'll help you make sense of all of this mess. So first off, square root of 20, we're dealing with square roots. So what I did over here on the right is I wrote down what my perfect squares are. So 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. So these are the first 9 perfect squares. And so I look at 20 and I see, okay, so looking down this list, how can I get 20 from one of these numbers being multiplied by another number? Because I can't get it directly. And so I noticed, well, 4 times 5 is 20. So we're going to change this to be the same as the square root of 4 times 5, because the square root of 4 would be 2. So that would simplify to be 2 square root of 5. Looking at 600, how could I get 600 out of these? Well, right away I jump to this 100 and recognize 100 times 6. And I can't get 6 out of these, so I can't make that any better. So this would be the same as square root of 100 times 6. The square root of 100 is 10. Square root of 6 I can't simplify because that's just 2 times 3s if you were to do a factor tree for that. So that can't be simplified anymore. So it would just be minus 10 square root of 6 and 125. How can I get 125 out of one of these? Well, the only one that ends in 5 is 25, and 25 times 5 is 125. And the square root of 25 is 5, leaving us with the square root of 5 left over. Now what I notice is what's highlighted there, those are like terms because they're both square roots, and the radicand is also the same. So what's under the radical is the same. So 2 square root of 5 minus 5 square root of 5 would be negative 3 square root of 5. And then minus 10 square root of 6. By the way, it does not matter what order you write this in. So that would be your answer. So again, it doesn't matter what order you put those in. That would be your answer. All right, so let's look at multiplying radicals. Now remember back when we were doing in the previous semester, one of the tools that we used was the box method. So if you want to use a box method or if you want to distribute, either way would be fine. Personally, I'm going to distribute this one. On a different one, I'll show you that would be more beneficial maybe to use a box method. But for this one, I would just recommend just distributing when you have a single term outside of there. Now, if you recognize this 2 is not underneath the radical. So when I multiply that times a 2 times the cube root of 7, the 2 we're just going to park outside the radical. So this would be 2 times the cube root of 7. I read it just like that. Now with the cube root of 49, we can multiply those together. So 49 times 7. Now if I do 49 times 7, that's going to be a really big number when I multiply them together. But maybe what you might recognize is 49 is the same as, actually let me just erase it, it's the same as 7 squared. And 7 squared times 7 would be the same as 7 cubed. And the cube root of 7 cubed, well, the root undoes the power. So your answer would be 2 times the cube root of 7. And then this simplifies to just be 7. And these are not like terms, so we cannot combine those. So we'd have 2 cube root of 7 minus 7 would be your final answer. Now let's look at letter B. So letter B here, we have 2x minus square root of 3 times 2x minus the square root of 3. These are not conjugates. These are, it's basically just like saying 2x minus square root of 3 squared. But I'm going to use a box method for this one. Since we're dealing with roots, you might want to make your box a little bit bigger than normal. We'd have 2x minus the square root of 3 times 2x minus the square root of 3. So I multiply these, 2x times 2x, that's 4x squared. And this, a negative times a positive would be negative, and I'm going to park that 2x outside the square root of 3. Same thing with this, 2x times negative square root of 3, where it's going to be a negative 2x square root of 3. That's why you want to make your box kind of larger here so we can fit all this in. And a negative times a negative is a positive, and square root of 3 times square root of 3 would be square root of 9, which is 3. So it'd be plus 3 there. And now when we go to combine like terms, notice this diagonal. The square root of 3 and square root of 3, those are like terms. So we can combine what's outside and what the radical will stay the same. So in other words, your answer, oops, let me change to a pen. My answer would be 4x squared. And then when I combine those two, a negative 2x and a negative 2x would be negative 4x times the square root of 3, and then plus 3. So that would be your final answer. All right, now I want you guys to try these two. Now this one, oh, notice these are conjugates, so your answer is going to be slightly different from this one, from the previous one. So, but I would use the box method for the first one, and I would just distribute the square root of 6 for the second one. And then after you distribute the square root of 6, look to see if anything can be simplified there. So I'll let you try that on your own. So go ahead, try these two, hit play when you're ready to, so pause and then hit play when you're ready to check your answer. See how you did. So on the first one, you should have gotten x squared minus 10. How did I get that? Well, you take x minus square root of 10 times x plus square root of 10. Remember, when they're conjugates, that's what they are, same terms with the opposite sign in between them. When they're conjugates, the middle two are going to cancel out, because what happens is x times x is x squared. X times a negative square root of 10 would be a negative x square root of 10. And square root of 10 times x would be a positive x square root of 10. And square root of 10 times a negative square root of 10 would be a negative. Square root of 10 times square root of 10 is square root of 100, or 10. So this would simplify to be negative 10. So square root of, or x times square root of 10 minus x square root of 10, those two are going to cancel each other out, leaving us with just the x squared minus 10. For the next one, you distribute the square root of 6 through. So we get 5 square root of 6 plus the square root of 18. Now square root of 18, you could do the factory on that, or use this method that I prefer and recognize that, well, 9 is a perfect square. 3 times 3 is 9. So that piece would simplify to be 3 square root of 2. Now that can't be simplified anymore. 5 square root of 6 plus 3 square root of 2. That would be your final answer. All right. So this is a story problem where it says an artist wants to determine the area of her canvas. The height of the canvas is cube root of 13x, and the width is cube root of 169 x squared plus 6. What is the area of the canvas? Remember, area is just length times width, so we're going to multiply these together. So what we're going to do is we're going to multiply. Now, when I distribute this through, what I recognize too with 169, this is one that you're going to recognize because you're going to see it come up in a number of different examples and problems in your assignment. But 169 is the same as 13 squared. Also, just realize I forgot my x. So you might be yelling at your screen right now saying, Mr. Murphy, you forgot your x. Well, there it is. Okay, so now what we're going to do is we're going to distribute that cubed root of 13x times everything in parentheses here. And the reason why it was so important to change that 169 to be 13 squared is because it'll help us simplify it in this next step. So now when I take and multiply those together, since they have the same bases, we add the exponents, so that would become 13 cubed. Same thing with the x's. They have the same bases, so we add the exponent, you get x cubed. Whoops, and I forgot, I need to have this. So we'd have the, oh, actually, let's put the 6 in front. So we're going to put the 6 in front of the cubed root of 13x. So the cubed root of 13 cubed, again, that's going to be 13 because the root and the power undo each other. Same thing here, the root and the power undo each other, leaving us with just x. We'd have 13x, and then this will be plus, I'm noticing your guys' notes say minus 6, so change that to be a plus 6. I just realized that. But maybe you did that already. So then we would have 13x plus 6 times the cubed root of 13x. And that would be our final answer. All right, the last thing we're going to talk about here, I know this is kind of broken up into 3 parts. So we had adding, subtracting, radicals. We had to simplify those. We talked about multiplying radicals. Now we're going to deal with dividing radicals. Now remember when we talked about conjugates in the past, we've done these before with conjugates, just when we were dealing with imaginary numbers or complex numbers. Now we're going to deal with radical in the denominator. So same rule applies. We're going to multiply the top and bottom by the conjugate. So the conjugate of 2 plus the square root of 5 would be 2 minus the square root of 5. Oops. All right, so the numerator is going to stay because that's not going to change. So we're just multiplying that times 1. Now our denominator. Now I'm going to show you the long way, but this is the last time I'm going to show you the long way for when we deal with the conjugate. When you multiply those together, we would multiply these two and get 4. And when you multiply 2 times square root of 5, we get 2, oops, right. We get 2 square root of 5. And then when I take negative square root of 5 times 2, we'll get negative 2 square root of 5. And a negative times a positive is a negative, and square root 5 times square root 5 is square root of 25, which simplifies to be 5. And if you notice, these are opposites of each other. And all that we're left with is 4 minus 5, which is negative 1. So here's a fast way. When we multiply conjugates, all we have to do is multiply the first terms together. 2 times 2 is 4. Then multiply the last two terms together. Square root of 5 times negative square root of 5 would be negative 5. 4 minus 5 is negative 1, because the other ones are going to cancel each other out. Okay, so then that, technically we wouldn't want to leave like that. So what I'm going to do is I'm going to take this negative 1, or negative, and I'm going to move it up to the top. And simplify. So this would be the same as negative 2 plus square root of 5. That would be the best answer for that first one. All right, let's look at doing one of these together. Let's look at this first one. Let's do this first one together, and I'll have you do the second one on your own. So for the first one, what's the conjugate of 2 minus the square root of 3? 2 plus square root of 3. Remember what we just said. To simplify this, we're going to multiply the first two terms. 2 times 2 is 4. Multiply the last two. Negative square root of 3 times a positive square root of 3 is going to be a negative. And square root of 3 minus, or square root of 3 times square root of 3 would be square root of 9. Square root of 9 is 3, so we get just 3 there. And 4 minus 3 would be 1, so our denominator is 1. So that's kind of nice. So our numerator, we're going to multiply those together. Now, I would use the box method for this. These are not conjugates of each other in the numerator, so we need to multiply those together. So we do that. 2 times 5 is 10, so this will be minus 2 times the square root of 2. 5 times square root of 3, that would be 5 square root of 3. Square root of 3 times negative 2 would be negative square root of 6. All right, so now we have our first term would be 10. We don't have any like terms, so we're just going to have a giant numerator. So I'm just going to extend this out a little bit here. So then we would have plus, it doesn't matter what order we put these in, 5 square root of 3 minus 2 square root of 2 minus square root of 6. So that's an ugly one, but that would be your answer. All right, this is the very last problem, I promise. Why don't you guys go ahead and pause the video and try this last one on your own, and then see how you do, and hit play when you're ready. What you should have done, let's start with the denominator. Multiply those first two terms. 1 times 1 is 1. Multiply the last term, so negative square root of x times positive square root of x would be a negative x. So our denominator would be 1 minus x. There's nothing we can do to simplify that. In the numerator, I'm going to distribute the negative 4x through. So negative 4x times 1 would just be negative 4x. And negative 4x times the square root of x, we can't combine those, so we'll just write them as minus 4x times the square root of x. There's nothing we can do to simplify this answer, so that would be your final answer. So negative 4x minus 4x square root of x all over 1 minus x. So with that, good luck now as you work on your assignment. Remember, if you have questions, please feel free to reach out and shoot me an email or stick around for office hours.